rest of its life. Very important job. The James Webb Space Telescope is a truly remarkable observatory. People have been working on it for over 2 decades. Some people have been working on it for their whole professional lives. Thomas Zurbuchen is the head of science at NASA, and he's joining me now just to talk about it. Thomas, or Dr. Z, as we can also call you. The day has come. All these decades, all this time, all these people working on the telescope, and here we are, 16 minutes and counting to launch. It's a big day, huh?
Oh, I'm so amazed, right? We have this telescope on top of this rocket, a telescope that 10,000 plus people have worked on in many ways, and together with that telescope, all the hopes and dreams of those individuals, and also tens of thousands of scientists, some of them not even born, that will benefit from these data, are there with them, waiting for these last minutes of countdown for its journey to space.
I'm guessing people are feeling a combination of emotional excitement. What's going through people's minds, do you think?
Oh, I think there's a tremendous sense of accomplishment. Whenever you're on top of a rocket, many things went really, really well. There's tremendous pride. There's always a little bit of anxiety. We know launching is hard. We have one of the absolute best teams in the world working on this right now, so I'm confident in that. We're super excited. An amazing day today.
And what are you most excited about, Dr. Z?
Well, I'm a scientist, so for me, besides the technology that really is a marvel, it's really the best we can do. What I'm thinking about is really looking at the universe in new light. We have never seen the universe how Webb will show it to us. And can you just imagine going back in time, 13.5 billion years? It boggles your mind, even as a professional astrophysicist. Kind of just think about all the new things we're going to learn about our most beautiful universe.
Dr. Z, thank you very, very much for joining us. And I want to wish you and all the teams, everybody, the very best for today's launch. Thank you.
Go Webb.
So, yes, indeed, go Webb. So we are now 14 minutes and 30 seconds to launch. We're getting really close now. Everything's going well. All systems are green for launch. And I'm going to hand you over now to NASA's Rob Navius in the skybox alongside the European Space Agency's Luce Fabrichet, who are going to take on the commentary from here on in. Over to you guys. Rob.
Well, thank you, Katie. Merry Christmas to our worldwide audience from our broadcast booth high atop the Jupiter Control Center here in Kourou. Joining me today for this historic launch, my colleague Luce Fabrichet, the head of infrastructure and value chain for the European Space Agency. Luce, good morning.
Good morning,
great to be with you. Great to be with you today.
Very pleased to be here with you and all of you watching us for this very special event.
Well, at this hour, countdown clocks are ticking backward. We are at T-minus 13 minutes, 32 seconds and counting. Out on the launch pad, everything is in great shape. Don't let those clouds fool you. We are go for launch. The latest weather briefing just completed indicated that all weather parameters are green. We have a green board here in the control center, and everything has gone extremely smoothly in the countdown. About 9 minutes ago, a major milestone passed as the James Webb Space Telescope began the process and completed the process of receiving commands to transition from external power to internal battery power following the latest in the series of those weather briefings. Webb will remain on internal battery power until its singular solar array unfurls about 30 minutes after launch. Earlier, telescope controllers reported good environmental readings from sensors inside the fairing encapsulating the telescope atop the upper stage of the Ariane 5 rocket. And Luce, as we enter the most critical phase of the countdown, can you outline some of the upcoming critical activities as we head into the phase called synchronized sequence?
Yes, Rob. We are now reaching the end of this 11-hour sequence that we call the chronology, and that started yesterday evening. All systems here have been prepared for the final launch operations. And at the time being, it's rather quiet now inside the launch table and also inside the launcher. We were told a few minutes ago by the launch control center here that the launcher fluids and electric systems are ready for the final automated sequence. They are on hold now, waiting for the last weather report at -10 minutes. After this weather report, 3 minutes later, we will have the beginning of this famous synchronized sequence when all systems will be made ready for the liftoff. This sequence will first be run by the ground calculator, and then the onboard computer will take the lead step by step, and the launch vehicle will be made autonomous from the ground system. You know that we have 2 tanks in each cryogenic stage, upper stage and main stage. All 4 tanks are, of course, thermally insulated from the hot environment we have here in French Guiana. However, these liquid propellants are at very low temperature, and because of that, slightly evaporate. And to ensure they are perfectly loaded at liftoff, their final loading and topping up will last up to 4 minutes before the launch. So that will be the beginning of the synchronized sequence run by the ground calculators. Then we will have on the fluid side the end of the topping up, the final loading and the topping up of the different tanks. And on the electric side, we will have the onboard computer getting prepared for the launch also, and it will be uploaded with the H0, with the H0 time, the time for the liftoff, which is today at 9, at the beginning of the window, 9:20 local time, 7:20 Eastern time.
And Luce, we're coming up on that final weather report. We expect all systems to remain green. We'll be going down to the fishbowl to confirm that just a moment or two from now. It's a 27-minute ride to orbit from liftoff until the time that the Webb Observatory is separated from the upper stage of the Ariane 5 rocket. Several minutes later, the commands will be given to unfurl its solar array, followed by the confirmation from the telescope controllers in Baltimore that we are power positive, meaning that electrical current is flowing through that solar array. With us today inside the so-called fishbowl, seated with mission controllers on the floor of the control room, is Raphael Chevrier of Arianespace. Raphael, how's everything looking? What's being discussed down there?
Hi, Rob. Well, so far, so good. We just received the last weather forecast. It's all green for the H0 that is forecast right now. What we checked was altitude winds, wind in the vicinity of the launch pad, and risk of lightning. So right now, it's a relief because the weather was a bit tough in the last couple of days. But right now, everybody is very focused on the next steps. The start of the synchronized sequence at 7 minutes before liftoff. Last operations that Luz described earlier before Webb and the Ariane 5 are going to lift off and soar into the sky.
Thanks, Raphael. We'll be back with you and Luz here shortly. We now have confirmation from Baltimore that James Webb is on internal power. Amidst all of this activity, we cannot forget that it is Christmas Day. 53 years ago, the astronauts of Apollo 8 completed their 10th and final orbit of the moon after reading from the book of Genesis on Christmas Eve to billions of people watching with rapt attention back on our planet. The astronauts then headed for home following their spacecraft's trans-Earth injection burn. Today, more than a half-century later, we're just minutes away from another Genesis, the genesis of new era of discovery. The launch of the James Webb Space Telescope is at hand. We're just 38 seconds away from entering the critical synchronized sequence. You're going to be hearing all the critical calls from the DDO, the Range Operations Manager, who is Jean-Luc Voyer, here in the in the Mission Control Center. There he is. He will be calling the start of synchronized sequence, all of the critical countdown milestones, and we will be listening very intently for his calls. Let's stand by.
À tous de DDO, Attention pour la séquence finale lanceur. Top à 0 moins 7 minutes.
And with that, we've entered the period of synchronized sequence. You heard Luce Fabregat just a moment or two ago explain some of the critical activities, the first one coming up just a few seconds from now, which will be the topping off of the main stage tanks. The first or core stage was loaded earlier this morning with 175 tons of propellant, 150 tons of liquid oxygen, and 25 tons of liquid hydrogen. The upper stage loaded with 15 tons of propellant. That will be the workhorse for a 16-minute burn to lift James Webb to its final orbit. At separation, some 27 minutes and 7 seconds after launch, James Webb will be at an altitude of about 864 statute miles. To put that into perspective, some 520 miles higher than the Hubble Space Telescope and more than 600 miles higher than the International Space Station. Webb at that point will be traveling about 21,000 miles an hour as it heads out to a highly elliptical, halo-like racetrack orbit some 1 million miles from Earth to begin its scientific observations.
In a little more than 1 minute from now, we will see the 4 tanks pressurized at their flight level for the last tests before the ignition of the Vulcan engine. And in parallel, the electric system are also set in flight configuration, the onboard computer. The electrical power, as for the telescope, it will switch from ground to internal power 1 minute before the launch, 1 minute and 5 seconds before the launch. And we are going to see -6 seconds. At -6 seconds, we will see the disconnection of the upper stage, these big cryotechnic arms you can see on this picture. Then, 3 seconds before the H0, the inertial platform that will give all the information about where it is to the launcher will be released. And at H0, the 7-second sequence to ignite the Vulcan engine of the main stage will start. That will take 7 seconds, a little less than 7 seconds, where the engine will start up to its flight regime. Once the computer has checked that the Vulcan engine is running normally, and you will see at that point a flame going stable at the outlet of the nozzle, and at that point the onboard computer will ignite the 2 boosters that will enable to move the 770 tons of Ariane and Webb.
Coming up on the T-4 minute mark right now, just a couple of milestones real quick. At the 1 minute 5 second mark into the flight, Ariane 5 will go through the period of maximum dynamic pressure, max Q as it's known. That will be the period of maximum aerodynamic forces on the rocket itself. The solid rocket boosters, which will provide about 90% of the initial thrust off the launch pad, will shut down and separate at the 2 minute 21 second mark into the flight, followed 1 minute and 5 seconds after that by fairing jettison. That will expose the James Webb Space Telescope to the environment of flight for the first time. The main stage separation, or the first stage separation, comes at the 8 minute 47 second mark into the flight, and that will be about a 16-minute burn of that upper stage engine. It will cut off at about 24 minutes 51 seconds into the flight, and then we'll go into a coast phase of about 2.5 minutes to allow any oscillations to dampen out, provide the most pristine environment for the James Webb Telescope before observatory separation. We're coming up on the 2 minute 50 second mark into the flight. Again, you're going to be hearing critical calls down the stretch here from the DDO, or the Range Operations Manager, Jean-Luc Voyer. The weather is go. We have a green board, no issues being worked. NASA officials, including Greg Robinson on the right, carefully watching the telemetry, looking intently at the final couple of minutes of the countdown. Lives have been spent in the preparation of the James Webb Space Telescope that is about to fly.
And Beatrice Romero on his side, on the left of the screen, from Ariane Space.
And that is the DDO, the Range Operations Manager, Jean-Luc Voyer, as we have hit the 2-minute mark in the countdown.
The flight will be in 2 phases. You will see the first part of the flight during the solid rocket boosters phase. That will be the atmospheric part of the flight, the atmospheric flight, and the trajectory will be driven by to reduce the aerodynamic loads, and we will have a very different exo-atmospheric flight after that.
And you were watching a number of people, VIPs and invited guests, moving out to the observation platform that is right next to the Jupiter Control Center as we stand by for the 1-minute call from Jean-Luc Voyer.
À tous les vidéos, attention pour moins 1 minute. Top, à 0 moins 1 minute.
Thumbs up from Jean-Luc Voyer. All systems are go. We're inside a minute now, T-minus 50 seconds and counting. As you heard earlier, the Vulcan 2 engine will ignite. Turbo pumps will come up to flight speed for 7 seconds, and the command will be issued to ignite the solid rocket boosters. The James Webb Space Telescope will be on its way. T-minus 30 seconds and counting. Standing by for terminal count.
À tous de DDO, attention pour les décomptes finales. 10, 9, 8, 7, 6, 5, 4, 3, 2, unité, top.
And we have engine start. And liftoff.
Décollage.
Decollage, liftoff from a tropical rainforest to the edge of time itself. James Webb begins a voyage back to the birth of the universe. Punching a hole through the clouds, 20 seconds into the flight. Good pitch program reported.
Trajectoire est nominale.
Vehicle performance is nominal. The Ariane 5 rocket continues to fly uphill in nominal fashion. The rumble of the powerful Ariane 5 now being felt here in the control center. 3D animation.
We can hear the noise and feel the vibrations here. You're right, Rob. Yeah, impressive.
13 kilometers in altitude, 7 kilometers downrange, traveling about 0.6 kilometers per second.
Tous les paramètres à bord sont normaux.
The trajectory reported to be nominal by Jean-Luc Voyer, the Range Operations Manager. You can see at the bottom of your screen, the yellow line is the trajectory plot, perfectly overlaid over the green line, which was the pre-launch trajectory. 1 minute, 41 seconds into the flight, about 40 seconds away from shutdown of the solid rocket boosters. Coming up on the 2-minute mark into the flight.
When it detects the threshold on acceleration, not the deceleration, but less acceleration.
Tous les paramètres à bord sont normaux.
Everything is okay. Everything is normal.
2 minutes, 15 seconds into the flight.
When the computer detects this threshold, it will separate.
Séparation des EAP.
Done.
We have confirmation of solid rocket booster separation from Jean-Luc Voyer. This coming at an altitude of 44 miles. The Ariane 5 and James Webb traveling almost 5,000 miles an hour. We have about 1 minute, 5 seconds to go before fairing jettison. That'll be the next critical milestone.
The fairing is there to avoid the satellite being exposed to high temperatures and also high airflows. And as soon as the launcher leaves the atmosphere, as is now the case, the satellite does not need anymore to be protected, and Webb does not need anymore to be protected. So each kilogram being very important for the performance of the launch, we are going to eject this no more useful fairing.
And let's go down to the floor in the Jupiter Control Center to Raphael Chevrier of Arianespace. Raphael, so far so good.
Hi, Rob. So far, so good. Everything is nominal, as we say, when attitude and trajectory of the Ariane 5 is going perfectly well. As you can see also on the yellow line on the screen, we had the confirmation of the separation of the two solid boosters and now of the fairing, meaning that we have crossed the limits of the atmosphere. So everything is going super good. And the DDO just said that all parameters are going perfectly smoothly. So let's continue the mission.
And Raphael, this is a view from the upper stage camera called the Vicky Cam, looking back at the James Webb Space Telescope. This is on about a 20-second delay or so because of the way the imagery is processed here in the control room. There's your telescope ready to unfurl its wings, basically, and begin its journey to the Lagrange point, the L2 point, about 1 million miles away from Earth.
La trajectoire est nominale.
Trajectory is nominal. The report from Jean-Luc Voyer. The liftoff time confirmed here in the Mission Control Center at 12:20 Greenwich Mean Time, 9:20 a.m. Peru time, 7:20 a.m. Eastern Time. The Ariane 5 and James Webb, 181 kilometers in altitude, 450 kilometers downrange from the launch site here in Kourou.
Flight control is very smooth.
5 minutes, 12 seconds into the flight. We have about 3.5 minutes to go in main stage or first stage performance. And again, you can see at the bottom of your screen the yellow plot line overlaid over the green line, meaning we are right on course, right down the pike, and a perfect trajectory so far for the Ariane 5 rocket.
All telemetry data are now received by the Galileo tracking station, which is close to here, where we are in Kourou. It will track the launcher up to the ignition of its upper stage, and then we'll have the Natal station in Brazil, Ascension as you can see on the map, in the middle of the ocean, and the two last stations in Africa, Libreville and Malindi, one on the east coast, the other one on the west coast. And the one on the west coast, Malindi, you can see that the telescope will be separated more or less over this Malindi station. And this Malindi station will also acquire the telemetry data from the telescope. You can see both are green, Galileo and Natal, on this animation. It means they are expected to receive the data, and it was confirmed right now by the launch operations manager.
Acquisition de la télémesure par la station de Natal au Brésil.
And just confirming now that telemetry is being processed through the Brazilian tracking station. The telescope is also processing telemetry through the tracking and data relay satellite system. As it moves further and further out into deep space, all of the telescope's telemetry and its imagery ultimately will be processed through the Deep Space Network in Goldstone, California. We passed the 7-minute mark into the flight. A perfect ride so far on the Ariane 5. We have about 1.5 minutes to go in the first stage performance. Once the main stage engine is commanded to cut off, it will be jettisoned, and just a few seconds after that, the upper stage engine will ignite, and it will be the workhorse for a 16-minute burn that will put James Webb into its preliminary orbit. About 11 minutes from now, telescope controllers at the Space Telescope Science Institute will be sending commands to prepare James Webb for the initial series of commissioning activities that will lead to the deployment of its solar array and the initiation of generation of electrical power for the telescope. About 30 seconds away from main engine cutoff.
La trajectoire est normale.
Nominal trajectory continues to be the watchword for the day from the Range Operations Manager, Jean-Luc Voyer, as we stand by for main engine shutdown and separation.
Extinction de l'EPC. Opération EPC.
And we have main stage shutdown and separation confirmed here in the Mission Control Center and the ignition of that upper stage. And Raphael Chevrier down in the fishbowl. So far, so good.
Yes, Rob, we have the confirmation of the separation of the main stage and the ignition of the upper stage. The trajectory is perfectly nominal. This is a very important moment for us because it's always a challenge to switch on a cryogenic engine in space condition, and we are now at 220 kilometers of altitude. Speed is a bit more than 7 kilometers per second. As we enter now the second stage of the second phase of the flight, the upper stage is going to power for about 16 minutes to place Webb on its transfer orbit, and right now everything is again nominal, as the DDO just said.
And a short time from now, the so-called sawtooth maneuver will get underway. Again, like rocking a baby in a cradle, this will be a maneuver to keep Webb's optics protected from overheating, Luce.
Exactly, Rob, like a baby in a cradle. You can see here Webb attached on top of Ariane 5 upper stage with a very specific configuration. Of course, it will be different during its lifetime, but for the time being, its sun shield is folded and not yet fully protecting the observatory. A number of exhaustive studies have been performed by the mission teams in Europe, in the US, on the thermal conditioning inside the telescope and the way the rays of the sun would propagate and interact with sensitive equipment inside the telescope. Maintain this thermal conditioning is really key before separating this telescope. And in particular, we know that one face of the telescope cannot face the sun. That's why and to produce these right thermal conditions inside Webb, a specific roll law has been designed, what we call the sawtooth approach. And if you are watching carefully to these images, you can see this animation. You can see that the upper stage is going 30 degrees on one side, then 30 degrees on the other side, going back and forth this way to maintain this perfect thermal conditioning for the telescope.
It's worthwhile noting that after Webb separates from the upper stage of the Ariane 5 rocket, which continues to perform in excellent fashion coming up on the 12-minute mark into the flight, the telescope controllers will be taking the baton, if you will, from the mission controllers here in Kourou. The first steps will be the opening of fuel valves, a pair of fuel valves, to start flowing fuel to Webb's onboard thrusters. They then will power on the valve drive electronics. Those are powered on in preparation to control and fire those thrusters when required. Webb's solar array is scheduled to be deployed at approximately the 33-minute mark into the flight. Once it is locked in place, we'll get the call that electricity is flowing through the array. That call will come from the Mission Operations Manager, Carl Starr, who's at the Space Telescope Science Institute at Johns Hopkins in Baltimore. Seated right behind him in that control room is Alicia Starr, a pair of stars helping to guide James Webb on its discovery of the stars. Alicia Starr is the lead engineer for launch and ascent events. Once the solar array is deployed and declared power positive, then 3 out of the 4 hold downs for the aft deployed radiator will be released to prevent binding due to the cool down of the telescope's composite structure. The contamination control heaters will be enabled to protect instrument optics on Webb from any water ice condensation as they cool down. The actuator drive unit will be powered on. This particular mechanism helps with heater control of the fine steering mirror, preventing water ice condensation, later to be used to position each of the mirror's segments. All 6 reaction wheels and the wheel drive electronics will be powered on for Webb, and that will be the precursor to the attitude control system using those reaction wheels to maintain the proper orientation with the sun, as opposed to using onboard thrusters. Of course, fuel in those thrusters, very valuable. It's a limited commodity for the lifetime of James Webb's observations of the universe. We're 13 minutes, 55 seconds into the flight. Jean-Luc Voyer, the range operations manager, continues to report a nominal performance for James Webb. And again, Luce Fabregat from the European Space Agency, how is this trajectory being carefully and methodically adjusted to provide the correct parameters in the final stages of ascent?
Yes, Rob, as you can see on this plot, the altitude is slightly going down. It's perfectly normal. The launch vehicle is really on the line where it should be. This decrease of its altitude, slight decrease of its altitude, will allow the launcher to benefit and the upper stage to benefit of the gravity effect and to increase its velocity until it reaches a thermal threshold. It's about to reach it, or even already reached it now, and it will go up. And now it will go up and up to the separation of the Webb telescope. It will separate the Webb telescope on a highly elliptic orbit, but still around the Earth. The telescope will be released, inserted on an orbit around the Earth, with an apogee, a very high apogee above 1 million kilometers.
Trajectory nominal as reported by Jean-Luc Voyer. You see him in that view, 185 kilometers in altitude, some 4,500 kilometers downrange from the launch site here in Kourou, moving at more than 8 kilometers per second, right on the plot, right on the trajectory, everything looking great. We are about 9 minutes away from the completion of upper stage ignition. It's shut down, and then about a 2.5-minute coast phase before Webb will separate. Observatory separation will be called out. You'll be hearing those calls and the initial calls from Carl Starr, the mission operations manager at the Space Telescope Science Institute at Johns Hopkins, through solar array deploy and the declaration of a power-positive spacecraft. James Webb, of course, will be traveling well beyond the moon to a distance of about 1 million miles away from Earth, settling into a highly elliptical halo-like orbit to begin its astronomical observations. And again, as we mentioned earlier, at the time of observatory separation, Webb will be at an altitude of approximately 864 miles, statute miles, traveling some 21,000 miles an hour. We're about 8 minutes away from upper stage shutdown. The stage has performed as planned. No issues reported. The launch occurring at 12:20 Greenwich Mean Time, 9:20 Kourou time, 7:20 a.m. Eastern Time on this Christmas Day.
Very smooth. The velocity you just mentioned is very important, Rob. The velocity you just mentioned at separation of the telescope is very important. It will be slightly below, okay, I give it in kilometers per second, but it will be slightly below 10 kilometers per second, because it's important that the satellite, the telescope, is not inserted on an escape orbit. It will be placed on a terrestrial orbit so that there will be time for the layout, for the early phase operations and the commissioning of the telescope. And that will be, in fact, the upper stage that will leave this orbit and goes toward an escape or liberation orbit.
And of course, even though we're still in powered flight, the trajectory, the acceleration, the speed at which James Webb is going towards its preliminary orbit, all modeled in advance and carefully choreographed to maintain as quiescent an atmosphere and environment around the telescope for its ultimate separation from the upper stage of the Ariane 5 rocket, which is about 6.5 minutes from now. Eighteen and a half minutes into the flight. It's very quiet now here in the control center here in Kourou. NASA officials, European Space Agency officials, Arianespace officials, all watching telemetry very carefully. And as the upper stage continues to burn nominally and sheds fuel, the acceleration uphill for the James Webb Space Telescope continues to increase as we approach the 20-minute mark into the flight. Again, upper stage cutoff is scheduled at the 24-minute, 51-second mark into the flight, about 5.5 minutes from now.
After the cutoff of this main engine, as you said, Rob, we will have a short ballistic phase, a short coasting phase that will, when the upper stage will rely fully on its what we call the attitude and roll control system, and it will adjust its attitude so that during this so small ballistic phase, all the requirements from the telescope are fully met. And that at the separation, when there will be the separation, the conditions will be very smooth and as requested for the telescope. Beginning of life.
Today's countdown was as flawless as you can imagine. The weather was perfect all the way through the early morning hours, through the fueling process of the vehicle. The weather's been a bit dicey here in Kourou over the past few days, but everything fell together on this Christmas day to send a new present to the world's astronomer. 20 minutes, 40 seconds into the flight.
Trajectoire normale, tous les paramètres à bord sont normaux.
All parameters nominal as reported by Jean-Luc Voyer, the range operations manager. 4 minutes of powered flight remaining.
The telemetry of the launch vehicle is acquired for the time being by the Libreville tracking station on the western coast of Africa. Flight control is nominal. The trajectory is fully normal, fully as expected, as you can see on the plot with the yellow plot over the green one. That is the expected one.
22 minutes into the flight. Less than 3 minutes of powered flight remaining.
Smooth flight control.
And again, as we've mentioned before, everything nominal reported by the range operations manager. As we've mentioned before, this is a long ride uphill for the James Webb Space Telescope to put it at the proper position in the sky so that it can escape from the Earth, basically head beyond the moon towards its final orbit for its commissioning activities that will be the dominant feature of all of the operations from the Space Telescope Science Institute over the course of the next several weeks.
And the launch operations manager announced the acquisition by the Malindi station, as expected, for the end of the flight and the last part of the upper stage flight and the separation of the telescope.
James Webb is about 4 minutes away from separating from the upper stage. And again, at that point, it will be on its own. And again, those milestones that we discussed a bit earlier in the broadcast will begin to be followed carefully by the telescope controllers at the Mission Operations Center, the MOC as it's called, at the Space Telescope Science Institute in Baltimore. One minute of powered flight remaining. The upper stage continues to function perfectly. It's been a smooth ride for the James Webb Space Telescope.
Trajectoire est nominale.
That upper stage was loaded pre-flight this morning with 15 tons of propellant for this long 16-minute burn, now about 30 seconds away from upper stage cutoff. And we're standing by for upper stage shutdown and the cutoff of the upper stage engine.
Extinction ESC. Les paramètres à bord sont normaux.
The extinction of the shut-off of the cut-off of the engine was confirmed exactly as expected, with the exactly expected altitude and speed and velocity. So now we have entered the coasting phase, the ballistic phase, that will last for a little more than 2 minutes.
And the telescope controllers in Baltimore confirming that all of the function parameters for the James Webb Space Telescope have been loaded on board the telescope. We are expecting Webb separation at the 27-minute 7-second mark here into the flight. Just over a minute from now, Springs will gently push Webb away from the upper stage of the Ariane 5. As it moves further and further away from the upper stage, there'll be what we refer to as a collision avoidance maneuver.
Yes, Rob, exactly. The springs already will give some distancing, of course, between the two objects, between the telescope and the upper stage. And then the upper stage will leave the trajectory of the telescope and makes a special maneuver to pass the telescope and heads towards a liberation orbit and leaves the telescope on its orbit without any risk of collision and without any risk of pollution towards the telescope.
And we're about 17 seconds away from Webb separation.
Séparation Webb Space Telescope. Go Webb!
We do have confirmation of observatory separation. The James Webb Space Telescope, amidst applause here in the Mission Control Center now taking its first steps in pursuit of cosmological discovery. It was a perfect ride to orbit, and all of the separation sequence events are running in good fashion according to the telescope controllers. And there is the view from the upper stage camera on the Ariane 5 looking at the James Webb Space Telescope as it moves gently away from its launch vehicle.
Fantastic pictures of this telescope.
Go Webb, go Webb.
Yes, go Webb.
Ironically enough, as we marvel on this view from the upper stage camera, this will be humanity's last view of the James Webb Space Telescope as it moves to its workplace about 1 million miles away from Earth.
Yes, you're right, Rob. Impressive, fantastic pictures. Yeah.
Now we'll be hearing shortly from the mission operations manager at the Space Telescope Science Institute, Carl Starr, who will be calling out the procedures that will lead to the deployment of Webb's solar array. And down in the fishbowl where there is jubilation, let's go to Raphael Chevrier of Arianespace. And before we do that, Raphael, a bit earlier than planned, but there is the solar array having been deployed. James Webb now has its array out as we stand by for confirmation that it is power positive.
Hey, Rob. J'entends pas ce qu'il me dit. Il m'a appelé ou pas? Il m'a appelé ou pas, Rob?
Non, il t'a pas appelé.
And there it is. There's your critical call. James Webb not only has legs, but it has power as it begins its journey and the commissioning activities to follow. And with that, let's go down to the floor in the fishbowl and Raphael Chevrier of Arianespace.
This is it. We have witnessed and the confirmation that Ariane 5 have safely delivered Webb into space. The upper stage is now being placed on a safe escape orbit around the sun, but honestly, I've got to tell you that these images are absolutely incredible, and well, it may be the end of the mission for Arianespace, but it's only the beginning of the journey for Webb. It's now on its way to the Lagrange point. Congratulations to all the team involved in the flight. Really, there is no words to describe the immersion that is happening right now in the fishbowl. So all I can say is good luck, Webb, and bring us incredible data from the deep universe.
At that point, our sequence will continue.
Well, Raphael, congratulations on a perfect ride to orbit from the Ariane 5 out of Kourou here today. A view here in the Space Telescope Science Institute. Their work just beginning on a new era of scientific observations. Luce Fabregat, it was a smooth ride to orbit. Everything went by the book, almost like a simulation, without any problems. And we thank you for all of your insight throughout the course of the day.
Thanks to you, Rob, and really a great achievement. I have many faces and names now coming up to my mind, and really you can be proud of what was achieved on both sides of the Atlantic Ocean. Thanks a lot to you.
Tremendous jubilation here in the control center. You're looking at Jean-Luc Voyer, the range operations manager. Quite a Christmas present for the world's astronomers as the James Webb Space Telescope begins its life heading towards deep space. With that, we're going to go back to the floor now to Katie Haswell. Katie, we did our thing. It's up to you now.
Oh my goodness, I just can't tell you. It's such utter jubilation here on the floor in the Jupiter Control Center. Everybody's been whooping with joy. The controllers here and the mission controllers jumping up, clapping, whooping with joy, people hugging. And I have to say, my throat was caught as I saw the glimpse of sunshine on Webb solar panels as we watched it heading out into space on its journey to its working zone. It's going to take about 6 months before we start getting our deep space observations from Webb. Of course, the teams have got a huge amount to do before we get to that, and our best wishes with all those teams in Baltimore. I want to get some reaction. Right now, everybody is talking and hugging each other because they're feeling so excited, and I totally understand that. Let's start, though, by going over to the NASA administrator, Bill Nelson. Sophia.
Okay, can you go on right now?
Okay.
Administrator Bill Nelson right now looking at these jubilant scenes here in the Mission Control Center in Kourou, the European spaceport in South America. There are the teams. The mission controllers have done a fantastic job. It was an utterly flawless launch from the European spaceport here on the equator in the Amazon rainforest. Hoping to go over now to NASA Administrator Bill Nelson to get some reaction from him.
All stations, 7.5 minutes, give or take, until the sequence continues with our ADIR release part 1 and our TCS configurations.
GSC on off, filling the JW6 config.
The range operations manager has been calling out the milestones throughout the flight today. And the ESA teams responsible for so much fabulous work, great teamwork here to get the Webb telescope into space, and Webb is now heading out on its journey, on its own, with the mission controllers, the telescope mission controllers in Baltimore, following those incredibly important first actions and first operations. Charlotte Bezko there, who's responsible for the ESA operations here at the spaceport. We're hanging in there, waiting and hoping to hear from the NASA administrator, Bill Nelson, who I have absolutely no doubt will be as jubilant as everybody here at the Guiana Space Center. Charlotte Besco, who has been working for, I think, most of her professional life in human spaceflight and now heading up the ESA operations here at the European spaceport. Over to you, Bill Nelson.
Okay, Katie, thank you very much. This is a great day, not only for America, for our European and Canadian partners, but it's a great day for planet Earth. Thanks to the team. You all have just been incredible. And over 3 decades, you've produced this telescope that is now going to take us back in time. It's a time machine. It's going to take us back to the very beginnings of the universe. We are going to discover incredible things that we never imagined. And isn't that typical of this team, where the impossible comes possible? I can't thank you enough on behalf of a grateful United States government. I can't thank our partners in Europe and Canada enough. The French launch team, the Arianespace, the flawless perfection of the vehicle. And now we have to realize there are still innumerable things that have to work, and they have to work perfectly, 344 of them. But we know that in great reward, there is great risk. And that's what this business is all about. And that's why we dare to explore. The James Webb Space Telescope is very much a part of that exploration. It's significant that we had the delays, and it kept us all the way to today, Christmas Day, when others long ago peered up into the sky and saw stars. But it's also another millennia before that a shepherd grazing his sheep would look up at the night sky. He became a poet, and he penned the words, "The heavens declare the glory of God, the firmament shows his handiwork." That shepherd, that poet, became king. And those immortal words in Psalm 19 encapsulate the expressions that we have today. The handiwork of God, as we peer back in time, over 13 billion years ago, capture the light from the very beginning of the creation. My congratulations to the team. My congratulations to NASA, to our partners. Go James Webb Space Telescope. God bless you, and God bless planet Earth. Back to you, Katie.
Nelson, thank you very, Bill Nelson, thank you very, very much for those incredibly moving words. Indeed, we're heading out to look at the first light of the universe. And Bill Nelson there, we have Stefan Israel with us from Arianespace. Bill Nelson there being so complimentary about the partnerships, the teamwork, and thanks as well to you guys for this fantastic launch. What a day, Stefan.
Indeed, what a Christmas gift today from the Guyana Space Center. We really want to thank NASA for its trust, the administrator, Bill Nelson. We have with us Thomas Zoburon and all his team, and our first thoughts are going to NASA. It is a journey of 20 years we have made together. We have worked as hell, I would say, to make this happen, and now it's done. I want to thank as well ESA, who is formerly our contractor for this launch. We have Joseph Ashbarer with us, we have Daniel Neuenschwander. We have worked end by end to make it happen. I want to thank CNES, Ariane 5 Design Authority, and our daily partner here in the Guyana Space Center. Philippe Baptiste is with us, Marianne Claire is with us. Thank you very much to CNES. For sure, I want to pay my tribute to Ariane Group, which is the prime contractor of Ariane 5, main shareholder of Arianespace, and which has delivered the launcher up to liftoff. And doing so, I pay also my tribute to Arianespace team. The Arianespace team have worked all this year to make this 14th launch of the year and this very special mission. Your dedication, your professionalism has made the success of tonight. Tonight is a great step for the space journey. It is also a great step for the friendship between the United States of America, Europe and France. So thank you very much to all of us. And now I think we can take a little bit of a rest, but we are going now to leave with Webb up to its final destination, to the Lagrangian point. Thank you very much. Thanks a lot.
Thank you very much, Stefan. And the Director General of the European Space Agency is Joseph Ashbacher. Joseph.
So Merry Christmas to everyone. And we have delivered a Christmas gift today to humanity, to people, to NASA, but also to all the people in this world. Because with this James Webb Space Telescope, we are really enabling new science, new excitement, but also really rewarding all the engineering and all the effort that has gone into it. And I'm really grateful for this success. We have delivered a mission into space. It's power positive, everything is nominal, and I'm very grateful to Arianespace and all our partners for all this work. Stefan Israel has already thanked all our partners, but let me also just very briefly recall that this was really a team effort. It was a team effort of the European team. We call it Team Europe, the European Space Agency, obviously providing the launcher with Arianespace, with CNES, with Ariane Group, with all our partners which we have to make this possible. And I really would like to spend a minute to thank all the people involved in this. Today is Christmas. Some of them are here, have been spent weeks here in French Guiana or at the sites where they have been working. It's a special moment. I know you have made sacrifices, but it's a special moment, and really thank you from my heart. But also thank you, NASA. Bill Nelson was speaking before. Thomas Zoburon is here with his team. Fantastic cooperation, and this cooperation between NASA and European team is really exemplary. And a big, big thank you, Thomas, and your people for what you have done together with us, that you have entrusted this precious spacecraft to us, which we could deliver, and I'm so happy today. I can tell you this is a very special moment. It's very nerve-wracking. I couldn't do launches every single day. This would not be good for my life expectancy, but I can tell you this was very exciting, very nerve-wracking, but really, really very successful, and thank you from my side. And congratulations, NASA, congratulations, science community. Big science is to come, and really, really happy. Thank you from my side.
Thank you very much. So the president of the CNES, which is the French space agency, is Philippe Baptiste, and he joins us now. Philippe.
Thank you very much. Well, as everybody here in the room, I'm very, very happy to see that everything was fine, everything is nominal. It's great news for NASA, for ESA, for all of us. I just want to thank all the people who have been working over the last 20 years on this incredible instrument, on this telescope, but also people who have been working on the launch. I'm thinking especially on the 500 people who have been working yesterday during Christmas Eve to prepare the launch, to prepare this successful launch. And I really want to thank them very much. People from CNES, from ESA, from NASA, from Arianespace, and from all the partners who were around. I also want to give a special thank to the French Armed Force of Guyana who made this launch possible. They were monitoring everything, and without them, nothing would be possible here on this site. So thank you very much for all of them, and thanks also to all people from Guyana who are supporting this incredible European spaceport that we have here today. Thank you very much.
Thank you, Philippe. So we now have a pre-recorded message from Lisa Campbell, who is the president of the Canadian Space Agency.
I am so proud to witness the highly anticipated launch of this extraordinary mission. Je suis très heureuse et fière de m'adresser à vous aujourd'hui. It's a remarkable feat of international collaboration to think of all the scientific and engineering coordination that made today's events possible. In fact, Webb is the result of close to 25 years of planning and development with our international partners. Notre participation au télescope Webb est l'aboutissement de plus de 25 ans de planification et développement avec nos partenaires internationaux. We're playing a big role on the world stage. Canadian excellence has helped make this flagship telescope a reality. Our participation in Webb is extremely significant. It's the largest space science project in the 60-year history of our space program. Webb est effectivement le plus grand projet de sciences spatiales dans lequel nous avons été impliqués depuis le début de notre programme spatial. The successful launch of this groundbreaking telescope bolsters humanity's quest for knowledge of the cosmos and ignites interest in astronomy for a new generation. The Canadian Space Agency is proud to have contributed critical instruments to this large-scale partnership as part of a global effort to spur the next great scientific leap. We're thrilled to take part in a mission of such enormous scientific promise. Nous sommes ravis de faire partie de cette mission extraordinaire. Canadian astronomers are excited to use Webb's data and benefit from the tremendous science opportunities offered by this one-of-a-kind observatory. We congratulate the fantastic team of over 10,000 people who put all their skills, ingenuity, and effort into developing the telescope for more than 2 decades. Bon voyage, Webb! Canadians will follow your journey with great interest.
And now I'd like to hand you over to Thomas de Brucken, who is the head of science at NASA. Thomas.
Well, Katie, what an emotional day, what an emotional time. We're here, all of us who have been working together for so many weeks, months, and years, and more importantly, our teams who are taking team images behind us, who have put in front of their lives as a highest priority for so many of them to actually get this done and get it done here, working even during the holiday times. I just couldn't be more grateful to the many, whether it's Arianespace, CNES, the European Space Agency, all the amazing people around French Guiana, the forces that are here, all the good people that have been such great hosts to our teams. All of them I want to thank. You know, whenever we look at launches, they're both an ending and a beginning. They're an ending of an engineering project on the ground, and with many amazing hours and challenges that are there, but they're a beginning. They're a beginning of one of the most amazing missions that humanity has conceived, and I'm so excited to look forward to the next setup of this telescope and all the science to come. Thanks to everybody. This is what we can do when we come together, Katie, as one, humans. It's just absolutely incredible.
It's wonderful. And Dr. Z, thank you very much. Massive congratulations to you all, to everybody who's involved in today. Huge congratulations from everybody here at the Guyana Space Center, and also our very best wishes to all the teams in Baltimore who are now monitoring those early operations of the telescope as it starts to unfold. I'm going to hand you back now to Goddard, but before I do, I just want to say from all of us here at the Guyana Space Center, Merry Christmas. Over to you, Michelle.
Thank you, Katie. I can tell you that here it feels like the dawn of a new age. Historians of the future will divide our understanding of the cosmos into eras before Webb and after Webb. Webb is this milestone that marks a bold effort to look backwards in time to the mysterious origins of everything. Of course, we move at human time scales, so here's what's coming up. In the next few weeks, engineers will unfold Webb's critical sun shield to begin chilling the telescope to unimaginably cold temperatures. They'll extend the DTA, the Deployable Tower Assembly, the structure that supports the Great Golden Mirror. And then finally, they'll unfold that mirror and begin the process of fine-tuning the system for work. Through it all, we intend to bring you live